Welcome to Architect 300. My name is Harry Pierson. I'm an architect with a lowercase a working on Microsoft's architecture strategy team. Those of you in the audience who are quite astute will notice that I am not, in fact, Pat Helland, who was originally the speaker for this session. Unfortunately, Pat has had a family emergency, and he's not able to be here this week, so we are having to sort of shuffle some things around. The Architect 300, 302, and 303 sessions are all changing. We're going to go over that at the end of the talk. This talk is called Metropolis, Towards a Service-Oriented Architecture. And essentially what we're going to talk about today is a vision for how we see the evolution of information technology over the course of the next 20 years. What we're doing is we're essentially drawing a parallel back to how cities have evolved over the course of the last 100, 150 years, and using that to apply to information technology. Because city evolution and urban infrastructure evolution is much further down the pipe than the information technology. So we feel that this gives us a real good sense as to where we're headed. And it heads in some relatively interesting places. We're going to start by talking about the analogy. We're then going to go look at SOA. Of course, SOA is the big buzzword bingo word of the day these days. We're going to talk about using Metropolis as guidance in the applications that you're building right now, and then we're going to wrap up. So we're going to start, of course, with the analogy. So if you look at the way that cities have evolved, again, over a course of the last 150 years, there's some things that you really notice. Cities grew up in isolation. It was very, very difficult to even travel 50 miles. I know most of the people who are in this room came a lot longer than 50 miles to be at this event today. So just the simple act of moving 50 miles, something that we take for granted, something that some of us do every day going to work, was an incredibly difficult process. And thus nobody really did it very often. So cities grew up in complete isolation. And as we all know, when things grow up in isolation, they're never the same. So likewise, our information technology shops have evolved in isolation. Now, in cities, eventually the railroad showed up, and suddenly the effort to move between cities dropped dramatically. Likewise, when the internet arrived, the ability to move information dropped dramatically. And we're seeing the same types of evolution occurring in information technology that cities went through in the late 1800s, early 1900s. And so by studying how cities evolved through the end of the 1800s and in the early part of the 1900s, we can really make some interesting predictions about where we think information technology architecture is headed over the course of the next 20 years. So a couple of things to quickly... so we're starting with the analogy. The analogy is broken into 8 parts. Cities map to information technology shops. Factories and buildings map to applications. Transportation to communication. Manufactured goods to structured data and operations, manufactured assemblies to these newfangled virtual enterprises, retail and distribution to business process, urban infrastructure to IT infrastructure, city government to IT governance. We'll drill into each of these 8 parts of the analogy throughout the rest of the talk. Now, one of the things to notice, of course, is there are a couple of basic assumptions around the world today the way it is today. The first off is that heterogeneity happens. When things evolve in isolation, they are never the same. Ever, ever, ever. Things are the same because express actions were taken to make them the same. So it isn't a surprise that your IT shops run something different from your IT shops, which run something different from your IT shops. And I'm not just talking about the stuff at the platform level, right? Windows, Unix, Java, Linux, mainframes, but then also the applications that run on top of that. Microsoft CRM, Siebel, SAP, PeopleSoft. Each of these different types of things is another layer of heterogeneity. And what's interesting is that that's not actually going away, right? You're no more going to get one homogeneous system as you are going to pave the streets of San Diego because they're not like straight. It's not going to happen. So moving forward and going forward, that's one of the reasons that Microsoft has invested so heavily in interoperability. It's one of the key things that Steve Ballmer talked about at the keynote today. It's great to have a great innovative platform like Microsoft Windows, but if you can't connect it to the rest of your infrastructure, it's valueless. And so we're investing very heavily in interoperability because of this fact. Going forward, IT investment is split. We're spending money on applications, but we're beginning to see spending money on on infrastructure. And this is a very, very difficult balance, right? We need applications in order to push the business forward, but oftentimes these businesses are building the same pieces over and over again, and what we'd really like is to push that down into the infrastructure. But how do you pay for that? And this is a balance that's very similar to the kinds of things that we're seeing in cities today between investing in the infrastructure and investing in the applications, investing in the buildings. And of course, we both have historic monuments to deal with. How many people here have historic monuments in their data centers that there's just no way that you can bulldoze? Standardization is nascent. We're making great inroads here, right? Web services are a great push in the right direction around standardization. But it's really only a small way down the standardization road. It's great that I can ship the bits from my Windows machine to my Solaris machine. But it doesn't necessarily mean that I can get understanding at the semantic level between those two machines. Does my idea of a customer match your idea of a customer? Right? It's great that I can send a web service that has that. I don't know what they're doing with the lights. Better down? Okay, we'll leave them down. It's great that I can send you a message that has my idea of a customer in it, but if you don't have that same idea of a customer, it doesn't really do you any good. We think that there's going to be a lot of standardization in this space, and we're going to talk about that through the rest of the talk. Because data standardization is nascent, business process is nascent. It's really, really difficult to do standardized business process if the data isn't always the same. And so we're not seeing very much business process being standardized. Today, business process is in your employees' heads. And until we start seeing standardized data, we're not going to see a business process make huge leaps and bounds forward. The final thing is that loose coupling helps investments. That's one of the key features of service-oriented architecture. We want things to be independent yet interconnected. Because the more tightly connected things are, the more affected systems are when they change. And if there's one constant in enterprise computing, it's change. So we want things to be connected for efficiencies, for interconnections, for interoperability, for automation, but we want those connections to be as loose as possible so when things change, everything doesn't break. So we're going to start by talking about how cities map to information technology shops. So again, we started by talking about the fact that cities evolved independently. People got together for commerce and manufacturing. And there was no connections. Not only were there no connections between the cities, there weren't really any connections between the buildings. You know, maybe you built it near a road, or maybe you built it near a stream, but the reality is you just built the building wherever the heck you wanted. There were no zoning laws or anything like that. It was very difficult to travel between cities, and so therefore cities evolved their own ways of doing things. Now in information technology shops, we see the same kind of gradual growth. You build new applications to fill business needs. Those applications evolve slowly, and they're independent. Every time you build an application, what do? You start by building it from the ground up, soup to nuts. New database, new middle tier, new user interface. You're not really building on top of much other than the platform itself. You're not building on top of the other systems because they are independent. B2B is still very, very limited today. We'll drill a little bit more into B2B later. The reason it's limited is because these applications are not compatible. Not just at the platform level, which is something that's getting solved in the relatively near term, technologies like XML Web Services, but at the semantic level. The ideas of business processes and the ideas of business entities differ dramatically in their implementation between enterprise applications. So these are big, complicated, slowly evolving environments that are driven by finances. You build new things in the city because of financial reasons. You build new applications in your information technology shops because of finances. There's a specific business need. That's why you build. That's why you change. That's why you sometimes tear down applications. We're seeing this real issue around investment ongoing. Are we investing in the apps, or are we going to invest in the infrastructure? And again, we both have historic monuments that you have to worry about. So that's cities and IT shops. So next we're going to talk about factories and applications. So there was a dramatic shift in the 1800s around the way that things were constructed. In the early 1800s, everything was hand constructed. Everything was hand built. And factories pretty much were independent. Again, like all the other buildings were, they were independent. It was very difficult to ship products the same way it was very difficult to move people. In the late 1800s, we started getting autonomous factories, but they were interconnected. They were near the railroad, so that I could move products back and forth between cities. This became a significant change to the way that application, getting my analogy mixed up, sorry about that, the way that the city evolved. because now it's really, really important to be near the railroad. Economy was driven by the flow of goods and people. Railroads took people to cities, between cities, and it took stuff, products, between cities. And the economic forces drove those changes. Today, we have almost completely disconnected applications. It's relatively easy to move what we call raw commodities, right? Email and chat, right? Maybe some HTML, images. Apparently there's a big thing in music being moved around on the network. But structured data, forget about it. You're not really moving very much structured data around. Going forward, we're going to see the same kind of connections between applications as we're seeing in the last 100 years around the connections between factories. They're going to become interconnected. They're going to be connected not only to each other, but to the infrastructure provided by the environment. And this is an economic decision. It's going to drive, the economics are going to drive these interconnections to occur. Because when you're doing these connections with human beings, it tends to be slower. It's very difficult to get obviously a human being doesn't operate at the same kind of level of performance. They are much more flexible. Don't get me wrong, right? Human beings are great. I'm a big fan of them. Human beings are infinitely more flexible than the applications, but they're also infinitely more slow, infinitely slower. My English teacher would kill me. So this independence but interconnection is a very, very critical piece. We've spoken about it a little bit. There are major advantages to interconnection, right? Applications today don't have any interconnection, which means that I can't build on top of each other. I can't drive demand or support demand from my applications. Going forward, we believe that we're going to start seeing this kind of interconnection between applications and into the IT infrastructure, which today is pretty much nascent. So that's factories and applications. Next, we're going to talk about transportation and communication. So when the railroads came, everything changed. There were these huge economic booms and busts. Anybody, that sound familiar to anybody? Makes the internet bubble look like nothing. It was massive. The railroad infrastructure was built for moving two things, people and raw commodities. Later, manufactured goods came along, but it was wheat and coal and wood that really built the railroads, and people. That's the reason the railroads were built. Changes occurred later because of the interconnection between cities, but that wasn't the reason the cities were originally built. And what was interesting is that suddenly things had to work together. Stuff from city A and stuff from city B had evolved independently, and so what happened? They were different. And when you brought them together into the same city, they didn't work together. And that was a big problem. The other thing that was interesting is that retail really started to happen. It used to be that you'd go to the store where the stuff was made. The idea of moving stuff to some central location to buy it was all new. So now you could start to pull things together for sale, and it really changed the way that retail worked. So then in the information technology world, we have communication. The internet arrives. Money and moving people virtually, right? We're not really moving people, but the idea of we're actually going to use a browser to access remote applications that I never had access to before, and of course raw commodities, primarily email, chat, and HTML and images. Raw data, structured data, not moving any of that kind of stuff. People moving or browsing fundamentally changed the way we looked at application architecture. We don't build applications the way we did in the early 90s today because of this internet connectivity. And we're going to see further changes because of this connection. So we've seen some change. We've seen dramatic change over the course of the last 10 years. But the next 10 years are going to be even more dramatic as new efficiencies are driven because of the interconnection. Today, those efficiencies are very limited because data is not standardized, and because data is not standardized, business process is very limited. Moving people and data and commodities fundamentally changes the problem. It fundamentally changes the way we look at things. In the cities, it drove standardization, it drove retail, it drove business process, and it drove consolidation. And this is one of the more scary parts of this talk. The small town that wasn't connected to the railroad died out. It died out because if you weren't connected to the railroad, you weren't anything. You couldn't get to you conveniently. Systems that are not connected to the common infrastructure, to the common internet, are going to die out because it's going to be more value in the interconnection than in the actual individual systems themselves. So that's how transportation and communication map. now onto manufactured goods and structured data. So in the early 1800s, products were handcrafted, and there was no real standard way of crafting. So you typically had to do a lot of what we call trim and shim. I need to make this part work with that part, I need to file it down, I need to stick some stuff in there, and then I can sort of get this stuff to connect together. And then Eli Whitney is famous for inventing the cotton gin. Eli Whitney had a contract with the government to produce rifles. And it was his idea to say, let's start trying to build these products, all the parts, all the same. All of the rifles, all of the trigger mechanisms, all of the stocks, so that we can interchange them, interchanging them. Now, it turns out Eli Whitney was actually not successful in doing this. But the idea of doing this lasted further along and was eventually implemented by other people. Unfortunately, one of the things that's going to occur because Pat's not here is that we're not going to get a chance to do the drilling down into manufactured goods and structured data talk, which was ARC 303. I promise you that we will get a chance to get that recorded and it will go up on the web. And there's a lot more drill down on how the historical evolution of this occurred. And that's very fascinating and is very fundamental to the way that we approach things today. By the late 1800s, even if Eli Whitney wasn't the one doing it, we started to see standardized approaches to manufacturing. We're manufacturing parts the same way every time. And that became the ability to drive efficiencies. When you can build the same thing over and over and over again, you can learn the ways that you construct that, even if you're doing it by hand, and drive efficiencies. If I'm a human being constructing rifle barrels, if I can do it the same way every time, I get to be really, really good at that. So that's a very efficient way for me to construct things. And so we're going to construct things in this sort of modular component fashion where everything is standardized. Companies that didn't work with the standards went under. They retooled to the new standards or they went out of business because the economic forces forced these organizations to standardize. I'll give you an example. It's really, really expensive to get a custom anything these days, right? Custom bike wheel, custom suit. These things are not, if you want to make them by hand, they're significantly more expensive. And when the standardized stuff is good enough, then it becomes really economically feasible to only purchase the standardized products. If you want to offer customized stuff, you have to pay a premium for that. Now, if you think about this from the terms of data, today, a lot of our information technology connecting, right, because a lot of you guys are spending a lot of time on interconnecting of systems. All of that work is essentially that same kind of hand trim and shim. Well, this data record has first name, then last name, and this one has the name connected together. So I'm going to write a little script to look for the space and cut it into first and last name. That's the kind of work we're doing today. Over time, we think that these data formats are going to become standardized. Now, we're not saying standardized necessarily in the form of data standardization bodies like the ones that Steve Ballmer mentioned that we're working with today. We actually think a lot of these data standardizations are going to occur in de facto fashion. So, for example, if you were going to pick two companies that are likely to be dominant forces in standardization of enterprise resource management, two of those companies you might mention are SAP, because of their dominant location in the ERP business, and Walmart, because of their dominant position as a consumer of ERP services. These two companies have got a lot to say about how the standardization of data is going to occur. In fact, Walmart's doing a lot of this kind of stuff today. You will do it our way or we won't connect to you. Over time, that's going to become the general fashion of which everybody's going to do things. It may or may not be Walmart's way of doing things, but over time it's going to be economically infeasible to do it any other way. I may have this really great customer record, but if it costs 10 times as much for you to connect to me as the next guy, because you have to hand manufacture the connection and hand tool the data transformation from your system to my system, you're just not going to do it. So this standardization of data is one of the things that's really, really interesting that comes out of this analogy. And I know a lot of people think about this kind of stuff and think, well, I don't really see that happening. It took literally 50 years for this to occur in the physical world. It's going to be, in some cases, a long process in our information technology world as well. This allows us to drive much more sophisticated business process. And so that's part of the reason that we think that this is actually going to occur. So it's very important to connect to other things. You don't build systems in isolation anymore. Every time I talk to a customer and it says, oh, well, we don't need to connect this system to anything else, I tell them, then why are you building it? If you're not connecting this to everything else, that's a sign that you're building a system that's destined for early obsolescence. If you're going to connect to these other things, you're going to have to, the economic forces drive it so that they're going to have to connect the same way. The implementations aren't going to be the same. Right? The way that SAP implements order processing and the way that Microsoft implements order processing and the way that Walmart implements order processing, those can all be radically different. But the way that you connect to those systems and the way that you send messages, that's the part that's going to be standardized. Not the implementation, but the interface. So that's how manufactured goods and structured data map. Next, we've got manufactured assemblies and virtual enterprises. In the early 1800s, factories built products soup to nuts. I mean, literally to the point of, we're going to build a table, we're going to go out and cut down some trees. Right? We're going to hand create whatever nails or screws or fastening products we're going to use to put the thing together. With the exception of some general tools like saws, everything else was hand done by the factories because there was no capability for me to move stuff around. There wasn't enough economic force for me to provide components locally within the city, but there was no reason for me to come up with any way of building these sort of pieces that other people could use to build parts. Over time, as the railroads connected these different cities, it became economically feasible for me to say, I'm going to build something. Like in this example, in the picture we have bicycle tires. And I can ship those to bicycle manufacturers who are spread out over a very large distance. And I can get to be really, really good at manufacturing bicycle tires or whatever it is that I manufacture. And so I can actually start to see value add by building on top of stuff that other people build. I'm going to leverage their knowledge and their expertise to build even higher quality stuff. And what happens? That drives efficiencies. I'm going to buy bicycle tires from the people who have the best bicycle tires, better parts, or the best prices. And if all I'm doing is spending my time building the same kind of product, I can get to be really, really, really good at it. I can get to be really, really efficient at it. And it gets to the point where I can make my specialty component cheaper than any of the other companies who are going to buy it from me can produce it themselves. In the information technology world, we call this a virtual enterprise. And let me give you an example of one of these. I'm from Seattle, so of course this example involves Starbucks. Starbucks, especially if you've been to Seattle, they actually have an ordinance in Seattle now. You're not allowed to open a Starbucks inside of an existing Starbucks. They're all over the place. And what do all the Starbucks need? They need customers and they need product to sell. Well, customers, the Starbucks guys seem to have that pretty well in hand, but you have to think about how do you get the coffee to the Starbucks? Well, Starbucks could spin up a distribution arm, and they could buy a bunch of trucks and hire a bunch of drivers and have them drive around dropping off, a bunch of coffee at the individual stores. Well, it turns out there are other companies that already do that, right? UPS is already driving through most of those same neighborhoods where Starbucks already are. So instead of spinning up a distribution arm, Starbucks hands big pallets of coffee and lists of where to send them to UPS. UPS can deliver that product much more efficiently than Starbucks can because they're already driving through. They can offer up better prices because they're not only delivering coffee, but they're also delivering other products to other companies and other people in those same areas. So they can do distribution for Starbucks significantly cheaper than Starbucks can do it themselves. Now, that competition, of course, the truth of the matter is that if Starbucks is unhappy with the way UPS is doing it, then they can start to look at other companies because it's not just those big brown vans driving around in the neighborhood, right? FedEx is driving around, Airborne's driving around. So if I'm unhappy with one organization, I can start to look at switching to another organization. But guess what? That requires standards, right? If I have to build completely different pallets and completely different forms in order for me to move over to use FedEx instead of UPS, then it becomes uneconomically feasible for me to change. So virtual enterprises, where we're going to start outsourcing part of what makes me, me. Part of what makes my company do, distribution of coffee to stores is one of the things that Starbucks absolutely needs, but they're not the ones doing it. They are handing that responsibility off to somebody that they can pay who can do it cheaper than they can do it themselves. And that's going to require data standardization and business process. Because you better imagine that there's a very sophisticated business process that flows back and forth between Starbucks and UPS. If Starbucks doesn't get its coffee, we've got to know which truck, where it is, why it isn't there. Right? That kind of business process really helps drive this system. Standardization allows composable stuff and composable data. the ability to build on top of what other people do. It also drives better efficiencies, which means better products, better quality, lower costs, or higher profits. So next we're going to talk about retail and business process. So in the late 19th century, people went to stores, right? So they'd take the train into the city, and the stores would run vans. So I'm going to take the van over to the butcher, to the baker, to the candlestick maker, the tailor, all of these different stores I would go to individually. And then suddenly people started to realize, I can bring this stuff to one central location. But that only worked if the stuff was the same between different manufacturers. Right? If my idea of a large t-shirt and your idea of a large t-shirt as different t-shirt manufacturers were different, then it was very, very hard to bring that stuff together into a standardized store. I could also start doing mail order, right? You drop a big catalog on my doorstep, I fill out a form, I send it to you, and a couple of weeks later, something arrives in the mail that I purchased. Well, if that's not the same every time, the mail order business doesn't work very well. How often do you buy custom goods, through a mail order or internet service? You don't, because you can't be sure what you're actually getting. It only works if you're always sure of what you're getting, standardized stuff. In the 20th century, you saw this trend continue to grow, and then Walmart came along and said, you're going to do it our way, we're not going to do it your way. And that represented a fundamental shift in power from the manufacturers to the distributors. And that's a rumble that we're still feeling in the retail industry today. Today in business process, we have three big ways of doing business process. Swivel chair engineering, where you have two monitors and you're going to swivel back and forth. That saves you having to get up. We have, this is the most common form of B2B, fax and pray. And then this is Microsoft's big addition to business process, Alt-Tab integration. So you don't have those typing errors as you copy to the clipboard and then paste into the next app. Okay, but seriously, we need to have data and operation standards in order to drive business process. We need the ability to interchange. It's sort of funny. The joke Pat likes to point out is, it feels like you're standing in the late 1900s saying, I know what you guys want. You want clothes that are a little too big or a little too small. But here's what's interesting about that. If I get standardized stuff, I can get it orders of magnitude cheaper. And people were happy to accept the stuff that was a little too big or a little too small because it was really, really inexpensive. Interesting corollary to this note, that's what actually led to daily bathing. Because before that, you only had one suit and it stunk, so there was no real point in taking a bath. Pre-allocation, the ability to handle standardized allocation of resources and goods, means you have to have standard ways of dealing with things. Right? If I'm going to send pallets of coffee to my distributor, I've got to be able to make sure that pallets and coffee and distributor and those elements, those business entities, are the same every time. And that's what's going to enable efficiencies in business process. Over time, we actually believe that business process is going to be the dominant force over resource management, the same way that Walmart has now made the retailer the dominant force over the manufacturers in the physical world. This was an amazing transformation in retail, and it's going to be an amazing transformation in information technology. It's going to take a while. Depending on the industry, I personally think it's going to take between 10 and 20 years. So this is a long process, but the economic forces suggest that there's no other way for this to evolve. So now we're going to talk about urban infrastructure and IT infrastructure. So when you get a dense, crowded environment, what happens? It smells bad. So you start building shared resources for the infrastructure for the city. Water, sewer, gas, electricity, broadband, and over time, who knows what's coming next, right? These services require two things. We need hookup at a centralized metropolitan place. We need an we need an electric generator, we need a place to take all the sewage, we need to have an internet connector provider, internet service provider, but we also have to have local hookups. In broadband, we call this the last mile problem, right? It isn't good enough to have it centralized. You also have to be able to connect it out to every single house and every single building in your city. And that can be extremely expensive, especially when you're dealing with things that have already been constructed. Retrofit happens. Anybody here ever been to Notre Dame in France? I guarantee you they did not build toilets and electricity when they constructed the place originally. But they retrofitted it. That happens. And in fact, that may actually be your most expensive cost. Retrofitting that old mainframe application to use your newfangled services may be a very, very expensive proposition. But if you can't afford to bulldoze that mainframe historic monument, you don't have many other choices. The other thing we see happening today is we start putting conduits out to the street. So when you build a new building today, you put a conduit out to the street so that whatever newfangled thing comes along, you can probably run it through that pipe. Are you guaranteed that whatever comes along will fit through that pipe? No. But you've got a good chance of it happening. Now this infrastructure, what's interesting about it is how is it funded? Sometimes it's public, sometimes it's private. I'll give you an example. Anybody who goes up to Microsoft's corporate campus, we are right off the exit on 40th Street off a freeway called 520. We bought that overpass. We paid for it. Right? Redmond said, you want to build more stuff? You want to move more people into your corporate campus? Fine. Build better infrastructure to get people on and off the freeway. So the same kind of thing is going to happen in application infrastructure. You want some new kind of service in your applications for security or federated naming and a directory, identity, or what have you. Build services that everybody can leverage, because it's not just Microsoft employees getting off on that overpass. Everybody gets the value of that. We're going to start to see the same kind of infrastructure occur in IT because your information technology shop is getting just as crowded, and we don't want it to start to smell bad. Now, of course, you need to have the centralized service. You need to have the centralized federated management, the centralized IT naming directory, security, all of that kind of stuff. But you also then have to hook it up to all of your applications. And your retrofitting your old applications could be, as I said, your biggest expense. Now, one of the things we're doing with web services is we're adding that conduit out to the street. If you've ever read the SOAP specification, which is the baseline specification that web services builds on top of, there's this header area, which is undefined by the SOAP spec. It's basically a place where you can put new stuff. So specifications like security and transactions and reliable messaging put stuff in that header. And new things that come along that we may be not sure of, like maybe manageability or identity management or whatever other things, we have a good chance of being able to put into that header. Is it a guarantee? No. But it's a really, really good way of thinking about how do I add this functionality later without having to retrofit again. And again, we're going to see competition between funding applications and funding infrastructure going forward. We need infrastructure for crowded environments. And we're going to continue to get more crowded, so we're really going to start to see this IT infrastructure be a big deal. We're going to retrofit into our existing applications, but when we do that, we're going to try and continue to build a conduit for the future. So as we retrofit these systems, we only have to do it once. And this is, again, driving a funding competition between your applications and your infrastructure, the same way as it drives a funding competition in cities between buildings and city infrastructure. So that's how urban infrastructure and IT infrastructure map to each other. The last part is city government versus IT governance. So it's interesting to think about how the city government actually works. To go back to another analogy involving Redmond and Microsoft, the next town over from Microsoft is called Bellevue. It's across the Lake Washington from Seattle. And Bellevue is a skyscraper town. They have a city vision of being another kind of, like another Seattle. So you've got big skyscrapers in Bellevue right across the lake from the big skyscrapers in downtown Seattle. Redmond has a city vision too. Their vision is, we don't want to be Bellevue. We're not a skyscraper town in Redmond. So what's interesting is that that influences the way Microsoft builds its campus. As you drive up 156th Street, on the left-hand side, as you drive up past corporate campus, are buildings 40 through 44, which is where most of the developer division is. The main campus is to your right. And as you drive, you'll notice that buildings 40 and 41 are 4 or 5 stories tall. Buildings 42 and 43 are 4 stories tall. Building 44 is 3 stories tall. The reason? That's where the county line between Bellevue and Redmond is. The border between 42 and 44 is where that border is. So we could build 4 and 5-story buildings in Bellevue. We couldn't in Redmond. Now, as it turns out, because Microsoft is such a good citizen, bringing in lots of money to Redmond, we've actually convinced them. We've actually now built several 5-story buildings on campus. You guys might have read about on various weblogs or whatever, the office team just moved into a huge building, building number 36. You know what? you can't see Building 36 from off campus. It's not a skyscraper, but you certainly can't see it. We're losing this projector again over here. Sorry about that, folks. But you can't see it from off campus. I'm not sure what the decision-making process is there, or what Microsoft and the city government had to come to what kind of an agreement, but obviously we've been able to convince them to allow us to have some flexibility in the way we construct our buildings. So we have to think about, how do you allocate resources? As it turns out, cities don't really control what gets built inside of them. They can constrain what gets built to some extent. We can say, you can build an IT company, but you can't build a sewer or a paper mill in our city because it's going to smell really bad. So you can control to some extent, but you can't force anybody to do anything. You can just force people not to do things. In your IT governance, you've got to start thinking about who makes these kinds of decisions. I was talking to a customer one time, and he was telling me that he has 3 business divisions. Division 1 likes to build mainframe apps. Division 2 like to build Java apps, and Division 3 like to build Windows apps, and we're beginning to learn about .NET. And the very first thing I asked him is, who's the most successful? He said, well, what do you mean? I said, well, which group is doing the best of those 3? Because, of course, I wanted it to be Microsoft, so I could then say, why do you have those Java and mainframe guys? I do architecture now, but I didn't always do architecture, right? He didn't know. He didn't have metrics. So I started to ask him about his governance strategy. Who's making the decisions? Why does this business unit get to do mainframe apps if they're the only business unit doing it and they don't have the economic forces, they don't have the economic support for it? They didn't have this kind of a governance strategy. You need to start thinking about things like who makes these decisions and what are the priorities? Because the priorities differ. Is it cost containment or is it growth? Because typically those are on opposite polar ends. You can't get cost containment and growth. How do you know who and when you're successful? And what are your goals? What's interesting, again, about cities is that when you control the way that American cities do, you're actually optimizing for growth at the expense of cost containment. Now, whether that's how you want to run your organization or not is up to you. But this kind of control and constraining system optimizes for growth over cost control. So that's the analogy. We've driven through 8 pieces of that. I'm going to quickly check the time. So looking to the future, we've talked a little bit about this history lesson about sort of from the 1800s through when single factory interchangeability occurred until 1980 when Walmart asserted itself. And like I said, we're still sort of feeling the effects of that. You are here, 1880. Now, this doesn't mean that it's going to take 100 years for this stuff to occur in the IT world. It is going to happen much faster than that. It's going to take 20, 25 years, in my opinion, for this whole thing to occur in our world. But it means that we have a lot of fun ahead of us. There's a lot of interesting things to occur. Communication and browsing, they're established. We're beginning to start thinking about virtual enterprises, business process, and standardized data. That's what's really coming down the pipe next. So now, if we take this analogy, let's turn it and look at something that our whole industry is spending a lot of time talking about, service-oriented architecture. Now, this first slide, if I recall correctly, yes. This is something that's been essentially borrowed from the Indigo folks. So if you saw Don Box, or you've read a lot of his stuff, you'll recognize these 4 basic tenets. The 4 basic tenets that Microsoft says the service-oriented architecture is about are explicit boundaries, autonomous services, sharing only schema and contract between those services, and compatibility based on policy. The driving reasons for these are independence and interconnected. We want things to be able to be interconnected for the purpose of automation, but we want those to be as loosely connected as possible so that as things change, things don't break. The more tightly you connect things, the more likely it is that when you change something, you're going to have to change both sides of the communication channel. And as that can have a cascading effect through your IT infrastructure, you want to build systems as loosely coupled as possible going forward. So let's look at today's application. Right? Today's application is built soup to nuts. Right? You manage your own data. It's not really connected to anything else. It's not connected to any infrastructure. You walk in the front door. You want to do something, and it's done while you wait. The application is sitting there. The user is sitting there. This is how we used to do manufacturing before this whole standardized process occurred. Now, you walk into the tailor, and you're sitting there waiting for him to make your shirt for you. It's very, very difficult to do mass production in this environment because you're doing everything by hand to no basic standards. You can't do things over and over again at a very high quality and a very high production rate if they're different every time. This is not service-oriented architecture. This is the way that we build systems today, though, for the most part. We're building silos, not services. So, to take an analogy that we're all familiar with is the mail order application. Or today, this would also be something like Amazon.com, right? You get a catalog, right? You either Sears dumps it in your doorstep. Well, actually, they don't ship that anymore, I guess, don't they? Or you go to Amazon's website. And Amazon's got this huge, massive website. It's a big part of their brand. People spend lots and lots of time on it, and it's a very small part of the business process. Because essentially the whole goal for the Amazon.com website is to create an order, right? That's what the same kind of a concept of is. I've got my mail order. I'm going to fill out a form, and I'm going to send it in. At some point in the future, I'm going to be notified of status, right? So maybe I'll get an email or I'll get a piece of physical mail saying it's on its way or it's back ordered. And eventually that product actually shows up at my door. We have standardization in both the products, but also in the messages, in the data itself. It's always the same data that goes in, regardless of whether you're ordering shirts or a lawnmower or a book or a DVD or a children's toy. This is service-oriented architecture. The people involved are autonomous. You are autonomous from the mail order service. In the case of Amazon, their big website is autonomous from the rest of their services. They can upgrade their website independently of the way that they upgrade their order processing systems. All that big website is to create an order. There's very explicit boundaries between you and Amazon.com or you and the mail order business. All of your interaction is with standardized data in the format of forms, and there are very explicit policies about the way that things work. When do you collect credit cards? When do you do in the case of products being back ordered? When can you cancel? When can't you cancel? Very explicitly defined. This is service-oriented architecture. Now, a lot of times, salesperson is maybe not the world's best analogy here. I like to think of this as a mortgage broker. I recently refinanced my house, and I was listening to my mortgage broker, who's married to another mortgage broker. You know, I'm used to people looking at me funny when I talk about technology, right? I speak a variant of what the hell are they talking about. My mortgage broker speaks a completely different variant of that dialect, and I don't understand what she's saying when she's talking to her husband. You know, arms and HELOCs, and who knows what she's talking about. I have no ability to fill out that stack of forms that I have to sign in order to refinance my house. But she does. She fills them all out. She's an expert. She's helping me fill out a request, right? Because what I'm doing is I'm essentially filling out a really, really big form that says, I'd like to refinance my house. This is a lot like a smart client application, right? Applications like smart clients are, you know, if you could imagine an application, a smart client that's running on your desktop that allows you to interact with Amazon, how is that different from the Amazon website? It isn't. That website and that smart client exists for the sheer reason to help you create an order. If you understood Amazon's business well enough and you had access to all of their reference data, you could hand tool whatever their internal format, and I don't know what it is, a request to order, you know, a book on Amazon.com. But it would be really, really hard, and you really, really wouldn't want to do it. And so that's why we talk about salespeople being like smart clients. They make it easy. They work offline because the mortgage broker is completely independent of the banks. She also represents many banks. Right? So maybe this bank doesn't have the greatest rate, maybe that bank does. She does all of that for me. I don't have to think about that. They take orders in, and they provide results back. Now the other thing is, over time, businesses grow. Right? In a small business office, everybody knows everybody else. Right? Every time I meet somebody, you know, obviously, you know, with a company of 55,000 people, a lot of people know somebody at Microsoft. Oh yeah, do you know so-and-so? Well, with 55,000 people, chances are I don't. Right? So over time, as companies grow, you have to formalize your processes. And so there are very specific ways that we go through and do internal processes, the way we share between different groups, the way that groups interact with field people, very specific processes. Over time, we call this composite services or composite business services, where I'm going to expose services that may be implemented by different departments as one endpoint, right? So if a business process comes in to take an order in from Amazon, that's going to affect lots of different divisions within Amazon. It affects their finances, it affects their warehousing, it affects their supply chain. It looks like one company from the outside, but the reality is it's lots and lots of different groups working together as one. We call this composite business services. And the truth is, this is one of the areas where we have a lot of learning to do as an industry. How do you compose up services into a larger business process? And then how do you build them in a way that you can decompose? How do you decompose what we traditionally think of as an application into a number of services that can be then rolled up into a number of business processes? Well, one of the things that we've learned is that the things that organizations do are pretty stable, right? Amazon takes in orders, they send out products, they process payments, but the business processes associated with those change radically. The order, when they occur, why they occur, how they occur, the how is stable, but the when and the why radically change. So by building systems that are composable, now we can start to address the need to vary the system as the business needs change. So we talk about reasons why we want to use a service-oriented architecture, and for us there's three primary reasons. We want systems to be autonomous. We want them to be independent, right? I want to be able to upgrade my HR system without affecting my ERP system. We want them to be connected, but we still want them to be autonomous. That's one of the basic four tenets of the service-oriented architecture slide you saw a few minutes ago. We want to be able to start to separate the concept of resource management from business process. We think that those are going to be implemented in separate services. There's a talk later in the week called ARC 402 that talks much more about the idea of service masters and service agents. What a coincidence. I'm actually presenting that one too. Finally, we want to be able to start enabling this IT infrastructure. The ability to supply services really helps with the infrastructure. We saw a demo of WYSI 2.0 this morning and how we can add security by doing declarative programming. Right? They had a wizard to do it, or you could like munge up the XML yourself. But I didn't have to write any extra code to do that security. I just had to enable it at the infrastructure level. Obviously, our platform and other competitive platforms are going to get better at providing those services. What is the easiest way to be able to access them from your application? So that's another reason to use services. We're going to enable new business models using web services and using services in general. We also see three different types of service use. First is greenfield. How many people here have greenfield applications they're building? Yeah, that's what I thought. A couple of hands here and there. The vast majority of you are dealing with existing applications. And so we talk about cleaving applications. I bet you didn't know we would be talking about cleavage today. Cleave is actually an interesting word because it is its own antonym. Cleave means to separate and to bring together. So that's the reason we like to use it. We want to cleave these applications apart. We don't want to have our inventory information and our accounting information running inside the same application. We want to cleave them apart. But then we want to cleave them together, interconnecting them with services. That is what we want to be doing around web services. That's how we want to... The book here that we talk about is disentangling the big ball of mud. Right? If I've got a big ball of mud, I want to be able to separate that off into its constituent parts and then stitch the pieces back together using loosely coupled services that I can evolve at different rates. Now, one of the things we need for this, we talked about the idea of schema and contracts. Again, this is another one of the basic tenets of service-oriented architecture. This is one of the things that we think we're going to see a lot of standardization around. De facto standards are going to emerge around the types of data. This is a representation of a product. This is a representation of a customer. This is a representation of an employee. And the invocations that those pieces of data represent. I want to order products. I want to resupply the warehouse. I want to promote an employee. It's great that we can deliver messages today, but there's no semantic compatibility between applications as of yet. These standardizations are going to occur in order to drive semantic compatibility between applications. So that if I say, gee, I'm going to use vendor A to do my warehouse supply chain management, and then later I want to move to another company because they provide a better implementation of this standard service, all I want to have to do is point that service at a new endpoint. Right? If I have to do a whole bunch of hand trimming and shimming in order to convert to talking from company A to company B, it's not going to be economically feasible for me to make that change. Companies are going to either retool for these new semantics or they're going to go out. They're not going to be able to be involved with this. It's going to take a long time for this to occur. I said earlier, it's going to take, in my opinion, somewhere in the neighborhood of 10 to 20 years. Now, one other thing we always hear about when we talk about web services is this whole concept of, well, XML bloat. You know, I'm really worried about XML performance, or XML takes a long time to process. I have some things we're not really going to get a chance to talk to you too much. You can stop by the Cabana and bug me if you want to hear more about this. I think that we're overpaying today for scalability and performance. This is my personal opinion. This isn't like any official, don't run out and put it on Microsoft says, Harry says. We're overpaying for scalability and performance. Performance is important, scalability is important, but performance and scalability are not what's causing your business applications to lag the business needs on orders of years. CIOs don't stay up at night thinking, God, are my systems scalable enough? They're worried about, does my business and my IT align? Is my IT services helping my business services? So when we start talking about performance, I don't normally spend too much time thinking about that. And this is an analogy we like to talk about, is that XML is a lot like cardboard, right? Sometimes the cardboard weighs more than what you are protecting, right? Nobody worries about the weight of cardboard when shipping very fragile, light products. It is a cost of doing business. Cardboard is a very malleable substance, and it's actually an incredibly large industry today, right? We think XML is a lot like that. It is something not to worry about. Over time, the XML processing is going to get a lot better, and performance is going to continue to go up. Some of that's going to be helped by better code. Some of that's going to be better performance, better platform. Some of that's going to be just Moore's Law, right? As systems get faster, XML processing gets faster. You get that for free because those guys at Intel and AMD are working on that. We don't spend too much time worrying about this. Now, when we talk about service-oriented architecture, we're not always talking about XML web services. I want to make a distinction about that. XML web services are a great way to implement service-oriented architecture. And the standards that we're talking about in this talk are all going to be built on top of XML web services, right? But EDI was a service-oriented architecture. It was inexpensive to build. It was slow. It was very, very difficult. But it had those same four tenets around service-oriented architecture, right? Services, the boundaries were very explicit. They were autonomous services. We only shared schema, though those were standardized schemas that were defined in a central location as opposed to between individual organizations. And policy was predefined. Granted, that was in English as opposed to something like XML WS policy, which is machine readable. But the same idea applies. And so going forward, XML is going to be the way that we achieve this standardization. That's going to be the standard representation we use. So now I want to talk a little bit about Metropolis as guidance. Quick chime check. Yeah, we've got about a half an hour. And then we're going to wrap up. So the first thing is to think about how cities mapping to IT helps us do a better job going forward. One of the things that's really interesting is that cities, in small cities, you know everybody. Trust and security isn't a big deal. Right? If you live in a small town, when you leave the house, you leave your door unlocked. If you live in New York City, you probably don't leave your door unlocked. As we get larger areas, most of the people you meet are strangers. And so you need to start having mechanisms to manage that trust. Things like locking doors, things like the police, right? We have the same kind of things that need to start happening in information technology shops. As we start to connect these systems together differently, more so, we need to be able to manage that trust. And so a lot of the federated IT infrastructure that we talk about has to do with security. Federated naming, federated directory, federated security. This is around managing the trust of strangers because you don't necessarily know everybody that you're connecting with. That's actually one of the most interesting things about the whole internet phenomenon is that the internet was the first, wow, that makes it sound like it's a fad. It's not a fad. We went through that phase already. The internet was the first time strangers got access to your information technology shop. And that is a trend that is just continuing to grow. And service-oriented architecture continues to grow that even further. So you have to have mechanisms to manage trust and security. Again, connectivity is the order of the day. The systems are going to continue to get more connected within your city, within your IT shop, and more connected outside to your business partners, to your employees, to your customers. We're going to spread the work across lots and lots of services. Some services are service masters. They surround resources. They protect resources. Some services implement business process. We've been calling those service agents. Using services, we want to start thinking about infrastructure. Right? How can I hook my application into common infrastructure that's provided to me by the information technology shop? And how do I figure out the right way to pay for this IT infrastructure? Finally, how do we start thinking about governance? The governance thing has been a pendulum. Right? When we swing it out towards a decentralized fashion, costs get out of control. But when we swing it over towards a centralized fashion, it becomes a bottleneck. And it takes a long time to get anything built. Obviously, right now, we're sort of on that, given the current state of the economy, we're on that sort of the cost containment kind of a phase. We think that having a service-oriented approach gives you the flexibility to start to provide standard ways of approaching things. You know, using governance to say, you will tie into our IT infrastructure, but we're still giving business units the capability to innovate and do the things that they need to do without being bottlenecked by the central IT resources. Applications. We talked about cleaving. We want to start taking applications and cleaving them into their component services, or composite services, not component. We're not talking about component in the terms of like an ActiveX object or a .NET component or a Java bean. We're talking about services. So we want to split it up into its constituent parts. Right? If you take an application like SAP, I think that there are probably hundreds of these constituent parts. We're managing lots of different types of data, employees, customers, products, orders. We are also implementing lots of different business services, business processes, excuse me. So we want to be able to separate those out and then connect them together with services. Now, the underlying platform has a ways to go in the evolution here, right? If you can imagine how hard it is to keep an enterprise-scale application up and running, imagine trying to keep hundreds of moving independent parts of an application up and running. Right? That's part of the reason that we're working on Dynamic Systems Initiative. That's not the dreary sky thing that Steve talked about. Dynamic Systems Initiative is our investment in improving the management infrastructure. Because without that management infrastructure, service-oriented architecture could really quickly swamp your operations group. So you need to think about that today because a lot of that stuff is still coming. But you still need to start thinking about building the systems today, designing these systems to work in the future. Applications are going to start to become services. Now, you're still going to have, eventually, somewhere, there's a human being sitting in front of some screen wanting to get something done. So applications are never going to go away completely. But a lot of time, applications, the parts of applications that we spend most of our time building, the databases and the business logic, are going to get pushed away into separate services. And that fundamentally changes the way that our applications are getting built. I recently talked on my weblog about the fact that I think that this causes the vast majority of middle-tier service to go away. As machines get faster and we decompose applications into smaller parts, the scalability requirements drop to the point where we can actually efficiently run the service inside the database. Of course, if you were going to do that, you need to have a database server that has a really rich programmatic model. And certainly that's one of the things they're adding in SQL 2005 is the CLR enhancement inside the database. We're also adding the SQL Service Broker in SQL 2005. We'll talk about that a little bit more down the road. We also want to think about smart clients. And again, a smart client isn't just an application that's a front end to one service. An application, a smart client, oftentimes is going to be front end to many services. You can actually start to think about, in some cases, I'm going to do some of the business process in that front end application. If it's a business process that's one group and one business division within your organization, maybe you don't want to build a big BizTalk server or some kind of centralized workflow solution. You can just bake that into the Smart Client app. And it may talk to multiple services on the back end. So the ability for not just to talk to one service from one supplier, but the ability to talk to multiple services from multiple suppliers, both inside your firewall and outside, is where we're seeing the client evolution occurring. ARC 302, which is going to be at 5 o'clock today, is going to drill a little bit more into this today. Again, without Pat, we're not going to be able to get as deep as we were hoping to get, but we're going to do a discussion around Metropolis, and we're going to talk a little bit about how applications learn, derivative of a book called How Buildings Learn, at 5 o'clock in this room today. Applications become services. I should have just kind of worked it. Communication and structured data. The connection of systems with networks inside your organization and then between organizations with the internet we believe is going to drive standardization of data formats and message formats. Right? This is a standard representation of a customer. This is a standard representation of a business, of a purchase order. Over time, the semantic differences between organizations are going to disappear because, again, the economic forces drive it that way. It's going to become too expensive for me to connect to a partner that does things a different way. There won't be enough business economic value for me to talk to them. Sometimes this is going to mean bulldozing applications. But again, web services are a big way to help enable this. Right? The ability to expose services directly out of my business tier logic, even on top of an existing 3-tier application, to retrofit these service access to it. Again, we think the standardization is primarily going to be de facto. In vertical markets today, we're seeing standardization, some of it being driven like at the federal level by things like HIPAA. We're also seeing standardization where you get industry groups together that decide on how to do things like, say, RFID. But we also think that a lot of this stuff is going to be based on the dominant players. That's how standardization occurred in the physical world. Nobody got together and said, these are going to be the standard sizes of bolts and nuts. Right? The dominant companies won out. Everybody else retooled or went out of business. Over time, business processes are going to be the dominant force in services. Today, what's the very first thing you do when you have to build a new app? You design the database. Primarily 3-tier applications today are about resource management. What's the data? What's the structure of the data? What's the business logic for who can access the data, who can look at the data, who can modify the data, how is the data modified, and then how am I going to actually present that data to the end user? Over time, we believe that resource management is going to still be there, right? Obviously, if you don't have data, you don't have a system. But business process and the ability to make changes to the way you interact with data is going to become the dominant force. I actually saw reference in a book that's coming out in a few months that I've been reading about the idea of a business process management server. Right? We've seen RDBMS, then a BPMS. Right now, I don't think there's a product on the market that's really close to being exactly what a BPMS is. BizTalk's getting there. It's probably the furthest along that pipe. But the idea of being able to manage business processes so I can evolve them not in the years it takes today, but in months or shorter in order to capitalize on business opportunities, new partners, changes in the marketplace, what have you. This is going to drive massive economic benefit. And that's why part of the reason we think it's going to happen. Essentially, we follow the money. IT infrastructure, it becomes really negative cost. It's really not cost conscious to continue to build the infrastructure for every single application, right? Every single building doesn't have its own electrical generator. It doesn't have its own roads. It doesn't have its own water treatment plant. It doesn't have its own, it's all connected up to the municipality. We're going to see the same things occur in applications. Services, again, help enable this, right? Because all of these different applications are going to run on, again, heterogeneity happens. They're going to be running on different platforms, not only from each other, but also from the infrastructure, right? So maybe you're going to use Active Directory. Okay, I'm biased, right? So I'm going to pick Active Directory for your naming directory. But not every single application in your infrastructure is running on Windows. Well, how do I talk from my Unix Java-based app to Active Directory? You do it with services. We actually have an implementation of DSML, Directory Services Markup Language, for Active Directory, for that kind of an example. Same thing would actually work in the reverse. If I had a open LDAP directory and I wanted to be able to, as my centralized resource, and I wanted to connect my .NET application to it, I could do that with services as well. This connection to the infrastructure is going to be very important, and it's going to be very difficult because the funding competes for infrastructure with the applications that you're building today. Finally, governance. We talked about that pendulum swing. Services provide a mechanism to sort of shoot the gap in the middle on this one. Right? We don't want things to be too centralized because then we get bottlenecked and it takes years to get anything done. We don't want things to be too decentralized because then costs get out of control. We want to be able to have a way to decentralize while constraining the things that the business units can do. We don't want to give them full freedom to do anything they want. We want to be able to say, look, you've got to tap into the IT infrastructure. You've got to run on top of this federated infrastructure that we're providing to you. We're going to control what you do by telling you what you can't do. That's the way that city government works today, and we think that that's a really good way to do governance in your IT shop going forward. Again, that's building for growth instead of cost containment. But as it looks like we're starting to come out of the current recession, that might be a really good approach. But you as a business have to make that decision. So now we're going to wrap up with the conclusion. We're going to go back and look at some of the slides we started with. Heterogeneity happens. Cities evolve independently, buildings evolve independently, your IT shops evolve independently, and the applications evolve independently. They're going to be on different platforms, using different vendors and different customers. We want to take that approach. Is going to continue to happen. Nothing is going to change that. This methodology, this mentality of thinking about IT shops like cities fits with that reality extremely well. You as an organization need to deal with how you're going to invest your IT dollars. Are you going to invest it in applications to support the business or in infrastructure to support those applications to support the business? And that is a funding competition that is going to continue into the foreseeable future. You've got to deal with your historic monuments, those big applications that you just can't bulldoze. Some applications are going to get bulldozed as this standardization of data and business process occurs, but not all of them. So what do you do with those ones that are the historic monuments? We think standardization of data and business process is going to occur. One of the things that you can start to do now is start to do the standardization internally. I was talking to a customer about 3 weeks ago. He has 24 ERP systems. The first thing I told him is you've got to start to get some kind of consistency internally across those 24 systems. We just published a white paper on Architecture Center today called Entity Aggregation and Integration, which talks about how you deal with business entities like contacts, customers, employees, orders, products that are slightly different in each of those 24 ERP systems. Business process, once you get the data standardization in place, you can start to drive the business process. Here's a quick hint about the data standardization. If it's going to occur in the industry, the groups that are the farthest ahead are going to be the ones that are going to be in the driver's seat around setting what those standards are. If these are going to be de facto standards, it's not going to be a bunch of people sitting in a room deciding it as part of a committee. It's going to be what's out there in the marketplace. So the sooner you get involved with this, the better off you're going to be down the road. And again, think about loose coupling. We want to make sure that as we update our systems, we don't break the other systems that are running in the organization. Services are the next generation of how we're going to start seeing our information technology systems get built. Understand as much of them as you can from all of the different vendors that you're using today. We want to stop building these application silos, what we call islands. It's important to be interconnected, but it's also important to be independent. That I know I've stressed that many times throughout this talk, and it's probably one of the most important things to walk away from. Interconnected and independent, both inside your organization and across companies. We've got enterprise application integration. We've got business to business. The way we think of it, it's all just hooking shit together, right? That's the acronym we've got to worry about. We want to think about cleaving your applications together and apart. Apart to disentangle that big ball of mud and then interconnect them back in order to be able to automate and drive the business forward. Now, I mentioned earlier a couple of technologies. This is the only slide that has any Microsoft technology on it. We've got some cool stuff coming. Microsoft is one of the leading proponents of web services in the industry. We just announced today the shipping of WYSI 2, which implements, among other things, WS Security, WS Secure Conversation, and WS Trust, I think. Obviously, we're going to continue to drive our implementations of the WS Star specifications, reliable messaging, transactions, metadata exchange, what have you. A lot of those products are going to be built into a technology known as Indigo. I imagine most of you at least have heard of Indigo. Indigo is the messaging stack that's part of Longhorn. We also have, of course, BizTalk Server today, which is, as I said, a business process management server, the ability to do both workflow and a lot of this message data transformation. BizTalk, we're still doing this hand-shimming conversion of data formats. BizTalk has some really great tools to be able to do that with. And then finally, Yukon has this new tool in it called Service Broker, which actually was designed by Pat Helland, which is probably why he has it included on his slides. This is actually the ability to start integrating this idea of service messaging directly into the database. So what's going to occur is I'm going to receive a message. It's going to end up in the database. And then I'm going to start a transaction that takes the message off the queue, all inside the database. So this isn't a two-phase transaction. updates whatever data is local in this database that I need to update as part of this message arrival, send out any messages that I may need to send out, all within the scope of a local transaction in the database. As I said, over time, when you take that combined with SQL CLR, the ability to program SQL Server 2005 using C# and VB.NET and other CLR languages really starts to give you the ability to just implement these services running inside the database, where they are extremely fast. Running this as a local transaction instead of a two-phase transaction on a middle-tier server is significantly faster. Eliminating the network hop between the middle-tier server and the database server is significantly faster. Now, you can only do this in applications that, or in services that are connected via asynchronous messaging. Right? So I'm going to send a message and I'm going to get a response back at some point. I'm going to shut the connection down to the server and get a response back at some point in the future. Maybe it's in 4 milliseconds, maybe it's in 4 seconds, maybe it's in 4 days. Right? It's going to depend on the service level agreement between you and that service. Some services are going to be slow, like my order processing service at Amazon. I hit the submit button. I don't know when I'm going to get that order confirmation, and I don't know when the order is actually going to show up at my doorstep. Other services are going to be extremely fast. So asynchronous doesn't necessarily mean slow. It just means being able to deal with the fact that you may not get a response back in time to keep the connection between you and the service open. And so baking that stuff directly into the database really can improve performance. What's also interesting when you think about stuff like Service Broker is, if I have some piece of very volatile data, like inventory of the latest Harry Potter book, the day that it shipped, all access to that is going to be sequential anyway. Right? If I want to update it, and you want to update it, and you are going to want to update it, each of those is going to occur in turn. So I'm going to get access to it, I'm going to lock it, you're going to try and get access to it, you're going to hit the lock, you're going to try and get access to it, you're going to hit the lock. So it's all going to happen sequentially anyway. So if you start thinking about these things in terms of asynchronous messages, which is primarily how we think about web service-oriented architecture, you're going to actually be able to improve performance because now you're not doing as much lock management because you're only doing these things in steps. Service Broker really helps you with that. It's not been a hugely, obviously it's not one of the most talked about features of SQL Server. You've heard much more about the XML support and the BI support and the CLR support. It's really an interesting feature for service-oriented architecture. Keep your eye on these technologies. But that doesn't mean wait. Don't wait to start building your services. The sooner you build these services, the sooner you start building some of the stuff that we're talking about here, the better off you're going to be in the future. The more you continue to build systems using old ways of thinking, you're essentially building planned obsolescence. Start building your services now. Start worrying about how you're going to get data standardization inside your enterprise. Even if those data standards aren't going to be the same as other groups, make sure you add an abstraction layer because you know that whatever data standard you come up with is going to be different from what the industry or what is the de facto standard eventually ends up at. You know that the messaging stack that Microsoft is shipping, and most likely other vendors that you might be using is shipping, is evolving. Today it's ASMX, tomorrow it's Wizzy, the day after that it's Indigo. So build that layer in there. So think about these things as you build this architecture. We, an architecture strategy, hand in hand with another group that you probably know very well, Patterns and Practices, are working on building a lot of this guidance for you. Look for the low-hanging fruit. One of the points that we like to talk about with B2B is that one of the fallacies of B2B is we attempted to automate 100% of the scenarios. You know, there's real money if you can automate 20%. There's real money there. And you know what that money can pay for? Automating the next 20%. So look for the low-hanging fruit. We provide guidance on Architecture Center, msdn.microsoft.com/architecture. We've also got Pat Helland's weblog up here, blogs.msdn.com/Pat Helland. My weblog is devhawk, devhawk.net. It's also the featured weblog on Architecture Center. So if you just go to Architecture Center, you can see it from there. So quick changes. Because Pat is not here, we have canceled Architecture 303. It was originally tomorrow morning in this room. It has been replaced with WinCO5 Plus. It was originally a Cabana session that's been promoted. I believe it's about Oracle 10G. It's not a developer or architecture track, so I'm not sure what it is. Architecture 302 is in this room at 5 p.m. We are going to talk about, we're going to try and make it a much more interactive discussion, less of a presentation. We are going to go through part of the deck that Pat originally authored, where we start talking about how applications learn, how applications evolve over the life cycle. What's interesting is that different parts of the application evolve at different rates, the same way that different parts of a building evolve at different rates. Additionally, we're going to have other members of architecture strategy and patterns and practice here for part of that discussion. Finally, Pat's architecture cabana section, ARC CO6, has been replaced with a speaker. We have Gurpreet Paul, who is a senior director on my team, and you all saw him. He's one of the ARC 5. He's our infrastructure guy. That's going to be at 1:15 in the track cabana tomorrow. I don't have that on the slide, but it's tomorrow. Gurpreet was the CEO of the Microsoft Systems Architecture Solution. So he is an infrastructure architecture expert, and he'll be there to talk to you and answer your questions about infrastructure architecture. With that, we have the standard slides they make everybody put in. We've got about 10 minutes, so if you guys want to do questions, I think the microphones are open. Thank you for coming, and welcome to TechEd, and have a really good time while you're here. Oh, one other thing, please go to ComNet and fill out your evals.
A question? Yeah. Hello.
Yeah. A couple years back, I heard the fiefdoms and emissaries speech there. You know, how does that map onto what you're talking about here?
Where are you? Are you there? Okay, there you are. When we start talking about, we're going to talk more about fiefdom and emissaries in the 402 talk. Essentially, fiefdom and emissaries are evolved into what we're now calling service masters and service agents. So it doesn't apply much to Metropolis, because Metropolis isn't really spent too much time talking about the different types of services. But when you start talking about services that protect resources, which we call service masters, that's essentially an evolution of what we call as fiefdoms. The service agents, which implement business processes and other long-running kinds of operations like processing orders and what have you, that's similar to what we used to call emissaries. Not exactly, because also emissaries was also a little bit like that sort of smart client piece. So the ability to have some kind of offline support or something, that was also part of emissaries. So emissaries itself has sort of been split into sort of two parts. The service agent, which does business process, and then the smart client, which can then sit in front of lots of different services. Did I answer your question?
Yeah, it did. Thank you.
Cool.
The other question was, it's a very interesting analogy, but one of the things that made Metropolis's work is a lot of different people making a lot of different independent decisions and building incrementally there. Inside corporations, it doesn't always work that way. It's a decision making at a different level. And trying to get corporations to fund, looking at things as far as, instead of building it the fastest, most expeditious way to get something going, which tends to be monolithic, but to build it as a service that others can share. You know, who wants to pay for somebody else's sharing of something? And it seems to be a real problem for getting these things to move forward based on the politics and the funding part of it, rather than it makes sense from a technical sense.
I agree with you 100%. I mean, I had a friend of mine who used to sell Active Directory, and he said that selling Active Directory was 90% politics and 10% technical. And certainly the kinds of things you're talking about are probably even higher politically, right? It's a real competition for funding between applications and infrastructure. And that's going to be a really difficult part. Why should I pay for something? Why should I spend more on whatever, you know, fill in the infrastructure name here, management, security, whatever, that other people are going to use if it doesn't help me? And that's where the governance comes in. If you say, look, you can't build this unless you do it this way, that's where you start to have to be able to apply constraints to how the business units build their applications. I think that it's important to actually allow more independence, to be able to allow more people to make more independent decisions. Because the truth of the matter is, they're actually doing it anyway, right? If you go to IT shop and you say, I need an application that does foo, and they say, well, great, give us, you know, $30 million in 10 years or whatever it's going to cost, they're going to go off and build something with Access and Excel that'll work, you know, outside of IT's, you know, vision, if you will, outside of IT's site, that will get the job done. So we actually call that, we were talking about, again, sort of to preview the 302 talk, we call that a low-road application, right? Yeah. So you're either going to have, you know, the high-road, highly maintained applications that IT is going to do, or the business units are going to go do something else. They're not just going to do without. So these independent decisions are being done either way. The question is, are you doing them in a way that's controlled, or are you doing it sort of in the wild, which is essentially how most of the people are doing it today. And that is certainly something that organizations are going to have to understand, that these decisions are happening anyway, so you're much better off understanding and controlling them and constraining them than just pretending that they don't exist.
Good point.
Another question?
Yeah, question on standards and how companies interact with other companies. The current business strategy that
Can you talk in the mic?
Sorry.
Yeah.
The current business strategy that a lot of companies employ is actually wanting to make it difficult for customers to move to other systems. So it's more difficult to lose that customer. Can you do both? Can you have a business strategy that right now states we want to make it difficult for our customers to leave by not employ standards, but then still develop for standards in the future?
Well, there's a couple of things with that. Number one, if you're tremendously successful, you are going to become the standard. Right? So other people are going to want to connect to you, and they're going to do it however you do it. That's sort of the Walmart approach, right? If you want to sell stuff at Walmart, they haven't gone to any standards body. They're just saying, look, you want to talk to us, you do it our way, and that's all there is to it. Certainly, I might have once or twice heard that whole lock-in mentality concept. I don't know where I might have heard about it, right? It's not like I've ever talked to customers. No, just kidding. But the truth of the matter is, if you look at history of manufacturing, it took 50 years, but that was the exact same problem. Right? We're not going to build things in a standard way because we want to be able to lock customers into our methodology, our products, and what have you. And again, when other people are doing it in a standard way and you're doing it in a locked-in way, unless you can provide literally orders of magnitude better value, then other companies aren't going to really be able to leverage what you have. If you're a little bit better and you cost a lot more to connect to, who's going to use you? Right? And that's where we think that the standardization is going to occur. Eventually, the economics is going to drive that to the point where you don't have much other choice. Now, it's going to take a while, right? It's going to take a long time. As I said, in the manufacturing industry, it took like 50 years. And it was a long, painful process. And my job in architecture strategy and architecture community is to minimize the pain and suffering of Microsoft's customers. So, I mean, literally, that's the way I view my job. So, getting this stuff standardized, it's going to occur. So what can you do now to start getting ready for that? And that's what I spend a lot of my time working with customers on.
Okay, thank you.
No problem. Any other questions? Yeah, we can take it privately. Thank you for coming, and I will, anybody who wants to come back, I'll see you at 3:02, or at 5 o'clock in this room. 3:01.